Enterprise Computing HSC course Unit 1, Data Science. So in this data science unit, we are establishing that data is the foundation of all systems. We need data in our systems because data is what supports our decision-making processes as humans, and also indirectly using AI to interpret data, and then us still viewing what the AI interprets to understand what actions we should take place within our enterprise, what we should do moving forward. So this whole unit is targeted at understanding data. So the first subsection is that of collecting, storing, and analyzing data. Three separate processes that are aligned with data in how we get it, how we handle it, and how we understand it. Firstly is understanding the difference between quantitative and qualitative data. Quantitative in the amounts of data we are getting, and then qualitative, how valuable that data is. We need to understand that distinguishment. This day and age, it's very easy to collect data and store data. But then that brings us to our next point of big data. The fact that we can get data very easily, but this data then accumulates and takes up file space. So we need specialized systems and make use of online storage for storing big data, because it is hard to store, but having that data is valuable because we can make lots of analysis and interpretations from that data. So we need to build our systems around the notion of big data. One fact that you might know about data is that we need to store data at specific data types. The way we store data impacts on its function, what software can be used with it, compression that can be applied with it, screen tools we can use to gather it and interpret it. So that is the data types, and the basic data types are text and a number, which can be in form of integers and floating points, okay? But then we also have booleans where we can select specifically if it's an on or off or a yes or no type of response within it. And then obviously the file extensions that can be applied to data as well. All of those impact on data's data type and interprets how a system will use that data. From here, then we have measurements applied to data. So a variety of different ways of scaling data and grasping how large it could be and how it could be used there. And there's some interesting terms there that I won't go into at the moment because I'm still learning them myself. From here, we've got data sampling, when we are getting data from the environment and putting it into the system. And one such area we know with data sampling is that of gathering audio data. That's actually called sampling, but we're going beyond that here too. And then the notion of active and passive sampling, when we are intentionally getting specific types of data or whether the system is doing it itself automatically and gathering data for us. We then have aspects related to data. Relevance, okay, how relevant is the data for the enterprise's operations? Accuracy, the correctness of data that we are getting, which we're using in our system. The validity, that data is valid and follows the appropriate rules for it to be correct by the system. And then the reliability of data in satisfying what we are using it for. So they do overlap. They are all features of each other, but all slightly different definitions there. Ultimately, that we are getting data for our system that is correct and meaningful for our operations. We then have informatics supporting our understanding of data. Now, this can be done in a variety of ways, but the way data is then starting to get displayed in the system, we can start making those interpretations, which brings us then to our next point of presenting data. And I've got this one in yellow because this might be ways you are presenting it within your assessment task through graphs and infographics, okay, which begin illustrating data and making them better to comprehend. Those spreadsheet style dashboards where we have data and it's represented visually, but then if we start changing the data within this spreadsheet, then the actual graphs that are on display and the pivot tables that are on display, they change live in response to the values we are changing. We can use data then to generate reports as an output of data that can be presented and have our own interpretations written on it. And we can also establish things such as network diagrams and maps, which can show obviously the makeup of different segments of a network or a geographical location and how data might differ in its as it's dispersed across a specific network or landscape. So all those features can be used to present data. Then we can talk about structured and unstructured data sets. And this can be affiliated with big data, but essentially as data is accumulated, is it in a structured format or is it just gathering numbers and we need to kind of structure it later and what we do there? Okay, so we need to differentiate between those two forms of data sets. Okay. From here, then we also need to gather sources of feedback based on our data or based on our system. Okay, where data is acting and we are getting it, but then what response are we doing in relation to that data? Because that's what it's all about. We get the data and we make a response. So it ensures that we know what our sources of feedback are. We have criteria to make sure that our feedback is effective and appropriate for whatever our system is doing. Now we then come to errors in data, and errors can be detrimental to operations, so they must be identified so that they can be addressed. Errors can come at the initial point of collection from our data sources, which is why it's so important to cross-reference our data sources. If we are putting incorrect data into our system, it will ultimately be incorrect information, and once processed, create incorrect values that our system will process. And we need to make sure we identify that so we then don't use those incorrect values as a part of our decision-making processes. As said, this stems to raw versus processed data. Okay, when data goes in raw, we haven't checked it. There could be errors there, and if it's then processed, okay, it will lead to incorrect operations taking place. So we need things such as validations and verifications in place to check data when it is entered into a system that it does go in correctly. And if someone accidentally does do a typo, okay, it will identify this is the wrong format or doesn't follow the range limits we've put on it. Okay, that there are rules in place to ensure that data, when goes into the system through validation, through verification, that ensures that it's entered as a correct format. But as said, if the data source is correct we're getting it from, it's still going to go in correctly. So we need to do our own research on our end to cross-check data and make sure it's correct. The other area of error related to data is that of bias, that we are selecting data sources that skew data to a specific way that we want it to be. This can be intentional or it could be unintentional, that we're just not doing a wide enough level of research and gathering data from a wide enough array of different sources for our system. So we've got to factor in that bias can lead to errors as well. And we've got to try to counteract that by getting data from a variety of locations in a bunch of diverse locations that fully represent the scope of data we're trying to represent within our enterprise system. The next one then is blockchain. Blockchain being that we can track the movement of data. And this is obviously heavily affiliated with cryptocurrency. And that might be the best way to understand it, that we can actually see how a cryptocurrency such as Bitcoin has moved through different ownerships, and we can actually track it from its inception. So we can actually track data. That's what blockchain is all about. So areas where blockchaining can be used is such as for online voting and tracking who's doing specific voting, um, online identities and what those identities are doing, the movement of specific items, when we this could be digital items or physical items, but knowing who has ownership on them, and thus support record keeping. We can put a name to these things. Okay, and I should specify with online voting too, they're probably not tracking the name of the person, they're probably just tracking their voting. Not, you're not allowed to track who they actually voted for or that, because it is meant to have anonymity to it and all of that. The next area is in privacy and security of data, and specific tools that we've got to be aware of where we might have to put security procedures in place. One such one, which is obvious, is autofill. It's great that our personal information and our financial information can be remembered by our browser and be integrated and inserted into text boxes automatically when we do an online purchase, but then there's a security factor related to that. So convenience can be at the cost of security, and we've got to weigh that up with our system. We also have that of private and public connections. It's great to go somewhere such as a public library and access a public network connection, but is it secure? Whereas if I use my own hotspotting or if I just do my work from home, I have a better private connection there. The use of checkboxes too can also be a factor in relation to security when we're switching things on and off and how it's being used. And then also terms of agreements for the things that we sign up for. Are we actually reading them? And that's a big issue because we sign up for a lot of things these days, specifically with online platforms, but do we fully understand what we're signing up for? It is listed in their terms of agreement. They do say, such as through social media platforms, how they're going to use our data, but we don't even read it because, sometimes we sign up when we're young and we don't even care. But those terms of agreement could say that they're going to use the pictures we're uploading to a platform as a part of their own business, okay? Or it could also limit what we can do as a part of their licensing agreement, how we use their specific data and platforms. So all this is important and it's all written within terms of agreement. It's just so long to read, and that's also an issue there in relation to privacy and security. And then we also have the impact of data scale, the amount of data that is available. We are very data rich these days. It's very easy to get data, as said with big data. So we've got to factor in the volume of raw data we're putting into our systems, how much we're putting in, where's it going to be stored, whether locally or in online platforms, which is more so the case so that it can be networked as a part of a large enterprise system. How data might not necessarily be downloaded from these online platforms, but it's more likely to be streamed live to keep the data off the local storage and keep it on the online storage for efficiency. The way machine learning interacts with data. So machine learning is obviously when the AI is learning itself. So based on it accumulating data, it changes its responses and interprets data in different ways so that accumulations helps it learn. Data can also impact on human behavior. Us as humans responding to data. What do we see? How do we change our actions in response to data? And then the ethical implications of data. What do we do in response to data? And also, where are we getting data from? Is it always ethical how we get the data? All right, and where can we read data from and who owns that data? So there's many aspects to data and specifically the collection and who is viewing it that relate to the ethics of it. Okay, not all data can be public because it's all about it relates to private individuals in some cases. So there's many ethical implications in relation to the impact of data. Okay, the final two things I'll talk about in this section is firstly data storage, how data will be stored. And I've already said it a few times that we have data that can be stored on the local storage of a system on its hard drives and solid states. We can also have local network storage where we have our own servers, but also these days as well, we have cloud storage and then a variety of ways that can be used. Public clouds, private clouds, hybrid clouds, and then that often is the foundation for the enterprise system and the sharing of data across a global network for that system. So that is then the data storage. But then we also have this thing called a data warehouse. Because we have so much data, okay, sometimes we take data from specific time periods. So it might be last year's data related to last year's customers, okay, and then we save that away to a data warehouse. Once put in that data warehouse, it might be then go with all our previous years, okay, worth of data in that warehouse. And we store it there to analyze that data using technologies such as OLAP, okay, which are used for data mining. And in that data warehouse, we then can look for trends and patterns in historical data that can support us in planning for future operations. So a very supportive tool, okay, for the storage of data, but the analysis of data, okay, and hopefully assist us with predicting successful plans for the future. The next section then is that of data quality. Data quality means that obviously data is correct and reliable, but data is meaningful for the operations of an enterprise. So, firstly, is the ethical use of data. As we already said with ethical implications, we've got this data now. We need to control who can view this data, and that might be linked to permissions and who the data is relevant to as a part of their operations within the enterprise, and also the sharing of data and data transparency, and the fact that we have people's personal data, we've got to keep it secure from cybersecurity and things like that as well. So we've got to keep an ethical lens on when accessing data, realizing data is valuable and we've got to keep it private. This links us to our social, legal, and ethical issues that are bias, which I spoke about before, where we can skew data in different directions and we should try to get data from a variety of sources. The accuracy of data and how correct it is, the use of metadata, the data behind data, okay, which is the fundamentals of databases and websites, and the fact that that also needs to be kept private because that has links to private information. Copyright of specific data and systems, and the acknowledgement of sources of data that are used within our systems, that we are referencing systems, companies, people who produce data when being used with our systems, and then stemming from that, IP, intellectual property, and then ICIP, indigenous cultures, intellectual property. Okay, that we know the laws that are around these things, and we've got to respect those laws when we are using systems and data that are under IP or ICIP. The establishment of permissions, rights, and privacy rules around data, which we mentioned before once again, to limit who can view data within systems. While we can all work for the same enterprise, we shouldn't all have access to all data of the enterprise. That's why permissions and rights are important to establish. And then our security tools for protecting our system and our network. Okay, our login procedures, our use of biometrics, encrypting data in transit and in storage, setting up a firewall for our network, a whole variety of tools built to protect our network from cybersecurity threats. Specifically on the legal aspects of data too, we need to know existing legislations in place, such as the Privacy Act 1988 and those principles that surround it. Okay, and then also if we're unsure about things and we need guidance, who are the responsible authorities? We know the government, but then who within the government? Groups such as the OAIC, who we contact in the instance of a data breach, things like that. Okay, that we need to know specifically who to go to in instances where there are concerns about data. Then we also need to know about data sovereignty of Indigenous peoples and how we support them and how data is used in the context of their cultures and their community. And we still respect their traditions and belief in how we use their data to support them. Okay, and then we've got curated and communicated data on social behavior. Okay, understanding things such as data literacy, how to actually specifically understand data, timelines of data and how it is used. Okay, signals and data swamps, and then educating users in this area. Once again, an area that I need to look in more to get my own understanding about it. So that final point is relevant to me too. But there's some key terms that are also very new to this course in relation to data and social behavior. The final section is processing and presenting data. So data has been processed, turned into information, and we're putting into a format that we can show stakeholders, clients, or peers so that it is ultimately comprehensible to them. So kind of the output of data that has been digested in a way for people to understand. And here you're going to see a lot more yellow boxes because it could correlate to things that we could have embedded into our assessment task. So first one is that of flat file databases, setting up a simple one table database that shows a variety of records, usually related to one specific area, that is done using a database package such as Microsoft Access. We also then have spreadsheet summaries for the collation of information. So this could be me as a user collating information within the spreadsheets, rows and cells and all that. But it could also be that I've got a form on the front end for the collection of data, that I've sent it out as a Google form and I've shared it with a whole bunch of people. And then when they enter in their responses, it updates in the spreadsheet. Okay, and then from that spreadsheet, I can then develop things such as graphs and tables that summarize data and make it more comprehensible, which then brings us to our next point of filtering, grouping, and sorting data. We can use tools within the spreadsheets to categorize our data and add filters so we can look at specific data sets and summarize data and focus on specific groups. We can link sheets with other sheets, and we can also make use of a thing called conditional formatting, where specific values that meet certain rules will be highlighted. Okay, it could be highlighted in red if a certain value is negative, or highlighted green if a certain value represents that a certain area is doing well. This helps us with data comparisons. And then, as said before, we can have forms acting as the front end for our spreadsheet, collecting data from a variety of clients and users, okay, for our to accumulate data within our spreadsheet. But then we could also have reports for our summary that we put this all into a formatted view to be printed off, okay, or sent out digitally that summarizes all the information for our stakeholders. A very modern tool used this day, and this is also in conjunction with spreadsheets, is that of dashboards. So dashboards are like a very graphical setup for a spreadsheet. And in many cases, we actually get rid of the grid of the spreadsheet. So that big tabular format kind of disappears. And it's all kind of text boxes and visualizations on screen that are used to represent the actual data. So there will be a few numbers on screen, but it's more the visualizations in the forms of graphs, but these graphs might change based on us entering different data and data sets. But that could be us manually entering it. We could also be using things such as pivot tables and slices. So tables that will shrink and enlarge based on what slices are active. So it could be that I have a specific category of information. You could think of it as subjects at school. And when I click English Advanced, only English Advanced students will appear in the table and the marks allocated to them. But then if I also click English Standard students and English Advanced students will appear in the table with their marks all together side by side. So the table will adjust depending on what slicer categories I have switched on and off. And then that could also be linked to a graph that is also adjusting accordingly and representing metrics in a visualized format. Visualization being key, and obviously visualization is now being introduced here, and that correlates with our next unit of data visualization in the Enterprise Computing Year 12 course. We then have the design of a relational database. So these are the databases that are larger than flat file databases and have multiple tables that we often refer to as entities. We create each of these entities using a data dictionary that allows us to establish metadata for each of the entities. What is the actual name of the actual categories in these entities, which we refer to as fields? Okay, what data types are they made up? Giving descriptions about it. How long will they be? How much allocation of memory will we give for each one? We provide examples of data and describe the data. They're all categories included in a data dictionary. As said, we use multiple entities to make a relational database, but we connect them through relationships through primary and foreign keys. Each actual entity needs to have a primary key, which is its main key, usually an ID field that is a specific number format, and then we can drag that over to as a foreign key, okay, the exact same number to another entity to establish that relationship. Once we have these relational databases set up, we can search them and sort them. And one very fundamental way of doing that is using SQL, structured query language, where we have a series of keywords used for selecting different fields and extracting it from specific tables, and then applying a condition using the where keyword, making use of operators to say if data is greater than, less than, equal to, or combining criteria together using and or. A whole variety of tools for searching and sorting within a relational database. But also there's things such as QBE within modern database management systems that can do all this for us using interfaces. But we're still going to know SQL because we're going to be doing this in a HSC, and we can't use software in the HSC. We've got to do it with our minds, writing out the specific code. And then we mentioned it before, forms and reports in relation to filtering, grouping, sorting data. Well, we can set them up using database management systems in a relational database for collecting data and displaying data at both the front end of collection and at the back end of displaying information. The final thing about this unit is that of machine learning and statistical modeling, and obviously very modern these days, and obviously a new part of the course in that we now have systems with neural networks that can learn themselves. So they accumulate all this data, they interpret all this data, and then they give us feedback and present the visualization itself, present the statistics to us in a formatted view, summarizing it for us, making our life a lot more easier because it is providing. Because one of the whole themes of this unit that you've seen with data science is how much data we are collecting now. Okay, terabytes of data, exabytes of data now. Okay, data amounts that we can't comprehend. And these larger enterprise systems are doing them daily. The amount of data. Think about how much data Google gets in a day. So if we can have machine learning supporting us in this processing and then giving us its output in a statistical format in a model that we can understand because it's a good summary of that data, that is of great benefit to us as humans. So I hope this video has given you an understanding of this first unit of data science. A lot of new technical terms in this unit, and essentially the purpose of the unit, understanding the foundations of data in how we collect it, how it is made, how we store it, how we analyze it, and essentially how it is of data quality, how it is of quality to us, it is meaningful to us in our operations. So we need to understand and be able to comprehend it. As said, this unit kind of then stems into the second unit of data visualizations, where we start turning data into a format that is comprehensible and usable and thus meaningful to present to people who aren't as educated in computing and in data, so they can understand it and use it for their purposes. But we'll get into that when we do our next mind map on data visualizations. But hopefully at this point, you understand what data science is all about for the enterprise computing course.